Welcome to lesson 3, fueling for strength performance. Just some general principles here. Gains in muscular size can benefit gains in strength and vice versa. This means that the nutritional strategies for strength are the same as those for size. And the exception between the two strategies is that when you train for maximal muscle hypertrophy, or rather, nutritional programming for maximal muscle hypertrophy, involves implementing a caloric surplus. And nutrition for maximizing muscular strength gains has, in some cases, the consideration of weight class limitations. So even though the principles are the same, the caloric surplus aspect is not necessarily there for maximizing muscular strength gains because of the weight class issue and limitation. But other than that, same principles. So acute fueling tactics, in other words, the timing of the meals and the nutrients relative to the training bout, they have to be tailored to the individual, but there is some pre-exercise considerations to maximizing strength performance. So training in an overnight fasted state is not going to optimize gains in muscular strength. And we're going to look at a specific study that observes that phenomenon. That's in the next slide. Oh, here we have the post-exercise anabolic window concept that I'm made a note for myself to discuss briefly. And this is because we went into depth about it in module 2 that focused on maximizing muscle hypertrophy. So briefly, the post-exercise anabolic window is a narrow 30 to 60-ish minute time frame immediately after the resistance training bout, where the legend goes that you need to consume a quickly absorbed carbohydrate and protein source during that time in order to maximize recovery and growth. And if you miss the window of opportunity, then you compromise your gains. So that is the post-exercise anabolic window concept. Now, this hypothesis was fine and dandy in the early 2000s when a bunch of very short-term studies, acute effect studies, seemed to support the idea. But over time, and with the publication of multiple chronic or longitudinal studies that lasted a number of weeks or months, examining the anabolic window concept and not demonstrating it as being valid, we just have to pretty much surrender to the evidence and figure that, well, the post-exercise anabolic window happens to ignore the impact of the pre-exercise meal on resistance training adaptations over time. And so we're kind of looking at sort of the wrong thing. We're missing the forest for the trees by looking at this narrow post-exercise anabolic window, in quotes, when it was more like a post-exercise garage door. And even beyond that, what we should be looking at if we want to optimize things and pull out all the theoretical stops to gains in muscle size and strength for that matter, is looking at the peri-exercise time frame, which is another concept that I discussed in detail in module 2 if you want to have a look. Okay, the macronutrient considerations for maximizing strength performance concentrate on getting enough total daily calories, which is what we looked at in the previous lesson. And they also involve getting your optimal total daily protein nailed, which is about 1.6 to 2.2 grams per kilogram of body weight. And you would be going by target body weight, unless your current body weight is your target body weight. And protein distribution. Instead of looking at a narrow post-exercise anabolic window, an ideal way to distribute protein is in 4 maximally anabolic doses through the course of the day. So the dose that maximizes the acute anabolic response, in other words, the dose that maximizes muscle protein synthesis, is 0.4 to 0.55 grams per kilogram of body weight. And you can, well, I've got the PubMed identifier down there at the bottom if you want to look up all the research in support of the text above it on this slide. But all you have to do is just Google Aragon, how much protein? And then the first search result will be my narrative review that I co-wrote with Brad Schoenfeld on how much muscle, how much protein maximally builds muscle. How much protein in a single sitting maximizes muscle growth. So all you have to do is just Google Aragon, how much protein, and you'll get that paper, which was published in JISSN in 2018. And we rooted out the literature and found that the range of protein dosing per meal that maximized that effect, that maximized muscle protein synthesis, was somewhere between about 0.4 to 0.6-ish grams per kilogram of body weight. So in imperial terms, that comes out to 0.2 to 0.25 grams per pound. And in absolute terms, for most people, that comes out to around 30 to 50 grams of protein. So in order to get the cake right and then get the icing right, you would nail your total daily protein, being the cake, and then get that distribution. Or you can actually experiment and see what's realistic. Because hypothetically, if you were to have 4 meals consisting of 0.4 to 0.6-ish grams of protein per kilogram of body weight, then you would be doing pretty much all we know of in the present day to maximize protein distribution for the goal of maximizing muscle size and or strength. So that is an icing on the cake thing. The cake is the total. And if you do get the total, then distribution of the constituent doses is a distantly secondary concern. So just imagine, like, if your goal is 150 grams of protein a day and you happen to get it in 350-gram servings instead of a nicer, neater 4 times 0.4 to 0.6 grams per kilogram of body weight, then that's fine. If you are in the fed state for the majority of your waking hours, which most people are unless they're only eating 1 or 2 meals a day, then as long as you hit the total for daily protein, you are getting the lion's share of your result. So optimal total daily carbohydrate for the purpose of maximizing muscle strength gains is around 3 to 6 grams per kilogram of body weight, possibly up to 8 grams per kilogram in higher volume cases. And fat for maximizing muscle strength gains is a matter of, and this, I want to emphasize that it's debatable about just how much optimizing testosterone levels can impact optimizing strength gains or strength performance. But it does have some effect. That we can deduce that it does matter. And if your diet severely or significantly compromises your ability to produce testosterone, and one way to do that is to be chronically hypocaloric, and another way to exacerbate that is to chronically underconsume dietary fat. So a low fat intake on its own, regardless of energy balance, is going to result in lower testosterone levels, not hypogonadal levels necessarily. But a recent systematic review and meta-analysis by Whitaker and colleagues took a look at this question and found very consistently that diets that were 25% of total calories from fat resulted in lower testosterone levels than diets that were 40% fat. So those are that's food for thought, and that's something to consider. And that's why I'm issuing the recommendation to construct the diet so that at least 20% of total calories comes from fat. And that is to just preserve testosterone production capability. All right, so gains in lifting performance over time drive gains in muscular size. And there's this bidirectional relationship between gains in size and gains in strength. But once again, with the objective of maximizing strength performance, sometimes there's limits to the amount of muscular hypertrophy that you would want, given the limits of a weight class, for example. But in any case, fasted state training poses a risk for lifting capacity, so it compromises it. In this particular study here that's referenced to the right, the breakfast-fed condition significantly outperformed the fasted condition on squat and bench press repetitions by 17.2%. So they did 10 more reps and 5.2% or 2 more reps, respectively, on those two exercises. And one group had breakfast and one group skipped breakfast. So the breakfast skipping group is the group that performed substantially less reps than the breakfast consuming groups. The breakfast itself was kind of interesting and worthy of at least an amusing look. It was a 600-calorie breakfast that had an extraordinarily high amount of carbs, 116 grams of carbs, and an amazingly low amount of protein for the amount of calories in that breakfast there. It had 14.7 grams of protein, and it was very low in fat. So that's the composition of that breakfast: rice cereal, milk, bread, butter, jam, and orange juice. It's always kind of amazing to see researchers' decisions that they make when constructing study protocols. A lot of times with randomized controlled trials, they lack what's called external validity. So they can have a high degree of internal validity where they are very well controlled and all of the potential confounding variables are suppressed. And so a study can be very tightly done. And the problem is sometimes they can lack what's called external validity, which means real world relevance. So if I were to redesign this breakfast, I simply would have traded out some of those carbs and just added more protein, perhaps made the protein an optimized dose for stimulating muscle protein synthesis. And so we'd have a little bit more realistically reflective dose there of what people might do in the real world if we added more protein to this breakfast. But nevertheless, we're able to at least see on face value that this very high carb breakfast outperformed skipping breakfast for strength performance. And we can take that data, we can absorb what is useful and reject what is useless from it. All right. So that concludes lesson 3. I'll see you back on lesson 4, where we talk about the carbs versus fat battle for fueling athletic performance.